also be written as a fraction, which is 1/3. So rational numbers are pretty much anything that can be written as a fraction. Also, 5 is a rational number because we can write this up as a fraction as 5/1. Examples of non-rational numbers would be 3/0. 3/0. Notice here it says A over B, where B does not equal 0. So this is not considered a rational number. The 0 is in the denominator. It is not a rational number. So make sure you write this definition down in your notes. And you will have to remember that for the rest of the school year. It's very important.
Juanita is reporting on pitching statistics. Pedro threw 80 pitches in all. He threw 10 splitters, 18 sliders, and 52 fastballs. Pedro's fastball statistic is 52/80ths. How can Juanita write the fastball statistic in decimal form?
Alright, when we are converting fractions to decimal, all you have to do is standalone division. So we have 52/80. Now to do standalone division, drop the top number in. So we have 52 divided by 80. Now you could simplify this to make it a little easier, but I'll just leave it as it is for now. So you have to figure out, well, how many times does 80 go into 50? Well, 50. You have to figure out how many times does 80 go into 52? Well, it goes into 52 0 times. Then we know we have to add a decimal and bring a 0 down. Now you have to say, well, how many times does 80 go into 520? 80 goes into 520 6 times. And then 6 times 80 is 480. 480 minus 520 is 40. Now we need to bring down another 0. 80 goes into 400. You could do mental math. Well, how many times does 8 go into 40? 5 times. So 80 goes into 405 times. So 52/80 written as a decimal is 6500. So whenever you go from fraction to decimal, you just have to do standalone division.
How can you write a rational number as a decimal? Let's use a bar diagram to show how the quantities are related. In what form is the pitching data represented?
Select your answer.
So what form is the pitching data represented? Do we think it's bar graph, line chart, or data table?
The statistics on the baseball card are displayed in bar graph form, with the first 3 bars representing the number of each type of pitch. Our bar chart only needs to compare the number of fastballs to the total number of pitches. The chart shows that Pedro made 80 pitches in all, with 52 of those pitches were fastballs. That means 52/80ths of the pitches were fastballs. Our next step is to convert the fraction to decimal form. Why should Juanita use a decimal for the fastball statistics in her report?
I want you to think about different situations where it's better to compare decimals versus fractions.
Statistics are often given as decimals. It's easier to understand the decimal than a fraction with a denominator of 80. Also, using decimals make it easier to compare statistics with other pitchers, games, or types of pitches. We need to divide to convert the rational number, 52/80ths, to a terminating decimal. A terminating decimal is a decimal that ends in 0.
Make sure you write this definition down as well.
80 goes into 52 0 times, so we place the decimal point in the quotient and annex zeros as we need them to divide. 80 goes into 520 6 times. 6 times 80 is 480. Subtract from 520 and you get 40. Annex a 0, leaving a remainder of 400. 400 divided by 80 is 5. 5 times 80 is 400. Our remainder is 0. Because the remainder is 0, the decimal 65 hundredths is a terminating decimal. Juanita can write the decimal 65 hundredths. Are 65 hundredths, 650 thousandths, and 6,510 thousandths equivalent numbers?
Alright, so sit and really think about this. Are those three terminating decimals the same? If you look here, the zeros after this 5, you don't need them. That's just extra zero. So if you take that off, is 6,500 and 6,500 the same? Yes, it is. Take off those two zeros at the end of the decimal, and it's still 6,500. So for example, if you have 7,5 hundredths, or let's use 80 hundredths, just like 86. 80 hundredths, the zeros after this number, you do not need them. You can still write this as 8 tenths. Now, if it was something like this, you cannot take off this 0 and think 8 hundredths is the same as 8 tenths. It has to be after the number. So any zeros after, they're irrelevant. You don't really need them. So all three of these numbers are the same.
Yes, they are equivalent numbers. If we continue the long division, every digit after 0.65 is 0.
Select each type of pitch to see the statistic in decimal form.
Alright, so the splitters, if we wrote it, it would be 10 over 80, and that's easy to simplify. This is how it looks in decimal form. Now the sliders will be 18 over 80. This is how it looks. And then what if we had total pitches, which is 80 over 80? It would look like 1, because 80 divided by 80 is 1.
Now you know how to write a rational number in the form of a decimal.